Morning. Welcome to the session on Storage Gateway Deep Dive. I'm Asa Calavade. I'm the General Manager for the Storage Gateway service. Joining me here on this session today, we have Adam from STEMCELL Technologies, Paul, who is a Product Manager on the service, and Everett, who runs business development for Storage Gateway. We'll start off with a few highlights about the Storage Gateway service, and then hand over to Adam, who will go into a lot of detail on the use cases that they use Storage Gateway for, the deployment architectures, some of the operational mechanisms they've put in place around management, monitoring, how they've done sizing of their service, et cetera. So you'll learn a lot about a real-world use case of Storage Gateway from Adam. And then we'll do a deep dive on two of our gateway types, the volume and file gateway. So these are some of the building blocks within the storage area. Today we'll focus on Storage Gateway, which enables data movement between on-prem or in-cloud data systems and AWS storage. Storage Gateway essentially enables seamless connectivity between on-prem storage or in-cloud storage and AWS storage systems. Customers use the Storage Gateway across their entire journey to the cloud. Some of our customers are just getting started with AWS storage, and they're using us to do backups or archives into AWS. On the other extreme, we have customers who've already migrated into AWS, and they use the gateway for low latency access to their data that's already sitting and running in AWS. So we have the whole spectrum of use cases that we'll talk to you about through this presentation. Our key focus here for Storage Gateway is to make this experience simple and efficient. The other day, one of our customers referenced Storage Gateway by saying, it just sits there and does its thing. And we actually took that as a compliment. Some of the key benefits that we offer through Storage Gateway are enabling existing applications to work with AWS. So we enable that through a number of protocols that we expose from the gateway. The low latency access is made available by having a cache on the gateway so that your frequently accessed data can be locally accessible. And then we've invested a lot of technologies on optimizing that data transfer between the gateway and AWS. And that includes technologies such as multi-threading, multi-part uploads, uploading only the data that has changed, low latency, prefetching, et cetera. So within the Storage Gateway family, we have three types of gateways. We refer to them as file, volume, and tape. The file gateway essentially offers an NFS interface, and you can use your existing NFS file-based applications, but yet move the data into S3 and get access to all of the capabilities that S3 provides natively. Volume gateway exposes iSCSI interfaces, so you can now write to volumes, which can move into AWS. You can create snapshots and get access to that data in the cloud. The tape gateway provides a virtual tape interface, and so you can use your existing backup applications to move tapes to AWS or archive them within Glacier. And all of this gets managed as part of your AWS service experience. So existing monitoring, management, identity, authentication tools all work within the gateway, even if you're deploying that on premises. The Storage Gateway is used for obviously a lot of storage-driven use cases such as backup, archiving, disaster recovery. But customers are also using this for more active workloads. So we'll describe through the presentation how customers use this for running analytic workloads in the cloud, or sharing data between sites, or tiering on-prem storage into AWS. We have customers across small remote offices right up to enterprise campuses that can deploy the gateway for one or more of these use cases. And our customers go across multiple verticals. So today we'll focus on STEMCELL Technologies and talk about how they're using it in their application. Adam?
Thanks, Asa. Morning, everybody. So I am the manager of IT at STEMCELL. I manage our operations and infrastructure groups, and I'm going to tell you a little bit more about how we use Storage Gateway for our hybrid environment. So a little bit about STEMCELL. We are Canada's largest biotechnology company. We're a privately held firm in Vancouver, BC, but we've got offices around the globe, specifically a big research office in the UK, which presents an interesting challenge. We've got about 1,100 staff today, and we are growing like absolute crazy. We're doing about 20% growth per year. Our motto is scientists helping scientists. So we are providing research products for specialty life science, specifically in the cell culture and cell isolation research use cases. We are a quality-focused company, and we are a high-performance product company. A little bit about our environment, just to give you a bit of context. So today, we're running about 45% of our workloads in AWS. That's typically an even split between infrastructure as a service, like EC2, running Windows and Linux. But we're also using a fairly good chunk of platform as a service. So we use RDS, we use Redshift, we use Workspaces. We're using AWS in 4 global regions to support our global staff, so we are spread across the globe. We use automation very heavily, so CloudFormation for both enterprise and line of business workloads. We use OpsWorks for dev and test to enable our developers. And we try to use native tools whenever we can. So Cloudwatch, Lambda, and EC2 Systems Manager all play a big part in our infrastructure. We've been an AWS customer for the last 6 years, and we've been running production workloads in AWS for the last 4. So we've got some exposure, we've got some experience, and we've seen AWS grow. The big change for us will be getting rid of our on-prem data center. So we are a science company. We are not in the data center business, we are in the science business. So we are working to move the vast majority of our on-premise workloads, whatever remains, up to the cloud and into AWS. But that said, we do have a need for very fast local storage to support our research groups. So why did we pick Storage Gateway? So to give you a little bit of history, we started looking at Storage Gateway way back in 2013, so we've seen the product for a while. We started testing volume cache with our research groups in 2014 out of a need and a requirement. We couldn't provide storage on-premise for them, so we looked for an out-of-the-box solution. We moved the remainder of our primary file storage, so general file storage, over in 2015. So 2.5 years now we've been using Storage Gateway for general primary file storage. And we picked Storage Gateway primarily in the beginning because it fit our workload best. We have a lot of instruments creating a lot of data. We have a huge focus on imaging, and our business needs high performance, low latency, local access to their data to analyze and capture. The side to that is we found often they're only using it for 2 to 3 months. So they need it fast and local for 2 to 3 months, and then they don't care about it. They want it available, but they don't care about it. Storage Gateway fits into that niche really well for us because it allows us to keep things fast and local and then have a full copy accessible and available. For us, we wanted to be able to scale cost effectively. As I said, we're growing 20% per year, which is an insane amount of disk to keep buying. Our data groups are growing even faster than that. It's exponential. So rather than buying disk all the time and buying new data centers and maintaining new data centers, we looked for a way to stop doing that. There's no point in us doing that, and Storage Gateway fit that need. At the end of the day, we really wanted to find a solution that was going to meet our requirements, both in our headquarters, where we do most of our research, as well as in some of our branches. So Storage Gateway is that product that scales both from small branches of 30 people all the way up through our headquarters of almost 1,000 in Vancouver. For us on the IT team, it's awesome. We like that we can use commodity servers. We can use what we have. We use, and I'll talk about it in a little bit, but there's just servers that you've got sitting in a rack, maybe something that's reasonably high performance. You can use that already. You can get Gateway up and running without a lot of hassle. We don't have a dedicated storage admin, and we don't need one. That's a huge impact to our team, and it means we can focus on delivering product to the business. For us, it's easy to do backup. It's easy to do DR, and we'll talk about that in depth as well. And the biggest win for us and why we moved over a couple years ago was there was no retraining needed. So our staff didn't have to change the way they worked. They were still able to capture their data to the same file share. They were still able to read and analyze their data in the same way, but they didn't. We were able to be more nimble on the IT side. They were able to continue to work in the way that fit them best. Finally, it fits our strategy. So we're cloud focused. We are cloud first. We don't want to be in the data center business. Our business is science. So AWS and Storage Gateway allows us to truly focus on that. It allows us to scale out really, really quickly. And for us, we have growing requirements around compliance and sovereignty, as I'm sure a lot of you do. We're able to keep our UK and EU data in region. We're able to keep our data encrypted end to end with the encryption built into Storage Gateway. So let's talk a little bit about how STEMCELL uses Storage Gateway today. So we primarily use volume cache, that is the core, and we use volume cache to provide primary file services. So we've got 6 total volume cache gateways deployed, 4 of which are in each of our 4 main sites. Those are deployed for general file storage. We've sharded our storage gateways, so each site typically has 2 to 3 departments. That means we can have a gateway which just supports those departments, as well as a Windows file server surfacing those files. It means we don't have to send a lot of traffic across the WAN, so it's typically very efficient for us to maintain that. Of the 6, we have 2 volume cache gateways specifically deployed for our research groups. So the workload for our research groups is very different. They were originally on our site-specific file gateways, our volume cache gateways, but we found that the amount of data that they were creating and the amount of data that they were changing was causing all other departments' files to be evicted from the cache, so they were having to pull down from the cloud every time. So we have specific gateways just for our research groups. In front of all of this architecture, so a shard per site would be a volume cache gateway running as a VM and a Windows server sitting in front. We've got Microsoft DFS. We're able to maintain a single global file space for all of our staff. So very, very easy to maintain. Native Microsoft technology on the front end, so easy for a Windows admin to handle, and then basically a black box sitting in the back. We have a couple other use cases. So we have explored and played and used File Gateway in a limited sense. We've got a visual media group. They create videos and build videos for our products. They have a huge amount of archive when you're creating 4K raw video. That's a lot of video and a lot of data to store. So we're using File Gateway to offload a lot of that from their primary file storage. They don't have a big throughput requirement. We're able to run it as a local VM on really cheap disk. It's basically something to get that data off for them. But what we like about File Gateway, is there's no LUN restriction. We can scale to the petabyte class. Whatever they need is local. They're able to write to local disk, so the file transfers from their primary storage to their archive storage is quick. And then if they need that data at a later point, it comes back slowly via the cloud, but often they don't need it. It's just there just in case. We did experiment and use Volume Gateway for about 18 months. We used a stored volume on-premise to back up our Oracle servers to. That allowed us to have both Oracle backups on-prem, so we could do a quick restore, and it was DR replicated up into the cloud. We're not using that anymore. We just ship everything to S3 directly. We've got our warm site in AWS, so really, really easy for us now to do it. But Volume Gateway in the stored mode certainly does fit a neat case there. Talking a little bit more about how we're actually deployed. So we've got VMware 6 running our entire stack. We're deployed on a mix of Blade and rack servers from Cisco, all UCS. Everything is VMware, storage, networking, all up and down is VMware. We run dedicated disk pools in VMware, so all of that disk is surfaced up through VMware. We're splitting our upload buffer, our cache, and our OS as per Amazon's best practices. We typically size our disk and split our disk by the workloads. So for the cache, it'll be on SSD or high-performance SAS. For the OS, it's not doing a lot of read and write, so we can reduce the disk requirement for that. For us, the disk is either direct attached or it's NFS-based. So in our big data center, we have a big NetApp, an NFS-based NetApp. So we're surfacing the disk in VMware through that. But we're actually finding it's often better through direct attached using an appliance-type VM or server. On the sizing front, we typically size our gateway appliances with 4 vCPUs and 8 gigs of RAM. For our high-performance gateways, so supporting our research groups, we double up the RAM, but the CPU is typically sufficient. So 4 CPUs, and 8 gigs of RAM typically gets you rolling. Then on the client side, everything is Windows Server 2012. We're attaching those gateways to Windows Server with iSCSI. We're following Amazon's best practices for that iSCSI, so we're actually tuning that window size. It's a 600-second window, which is really, really important. And we've seen performance issues way in the past where you do want to make sure that iSCSI window is tuned to 600 to make sure that iSCSI client and the iSCSI target have the chance to talk to each other in case they're pulling files down from the cloud. And we're using SMB2 on the front end. So DFS sitting globally, and then SMB2 surfacing those files to our client. Talking about the network design a little bit, we segment our network in 3 different realms. iSCSI for our server to talk to the gateway appliance. We've got a dedicated segment for our gateway appliance to talk up to the storage gateway service. And then we've got a separate client segment. This allows us to be very granular with how we control the traffic performance. Those NICs on the storage gateway appliance, you'll see them as ETH0 and ETH1. We deploy with VMXNet 3, so 10 gig all the way through on the backplane, and dedicated vSwitches. So we actually set up a specific vSwitch for each of these segments. We find that allows the best performance end-to-end. You're not having crosstalk, you're not having a lot of traffic. Each of our sites, so we have 4 main sites, each of those sites has a dedicated internet pipe going north. We've got dedicated bandwidth set aside for storage gateway. We do tune the upload and the download speeds in the storage gateway console. So you're able to go in there and tell it how much max up and down you want to handle. We've typically found 75 megabits, more than enough for what we're doing. It's not throwing any more than that. The technical max is 120 megabytes per second, but we're not getting anywhere close to that. Our storage is typically clearing and flushing up to the cloud well before we'd ever need that kind of throughput. To talk a little bit more about how we manage, how we monitor on a real-world basis, we use Cloudwatch to monitor everything. We monitor per volume, so the 3 big ones in there in green on the slide there, cache hit, cache dirty, and cache percent used. Those are the 3 that we really care about. Those are the ones that show us the most value and show us if we've got performance problems and if we don't have performance problems. We do monitor the upload buffer, but typically we oversize, so we don't see performance problems. I'm not terribly concerned around monitoring and alerting on that upload buffer. From an alerting perspective, 80% is typically the number we use for that cache hit percentage. So that's how much of the cache is being actually sent through. So any more than that, we're pulling a lot of files from the cloud, and we might want to upsize our cache as a result. That cache dirty as well. You can see on the graph, we're not even coming close to that 2.5, but that would be cycling data through. So we want to try to maintain our cache sizing so that we're not cycling a ton of data through. We do monitor in Cloudwatch the gateway read and write times. That's going to give us performance on the gateway level. That shows us in concert with VMware if we've got a disk problem. So if we're really hitting our I/O thresholds on our disk, we're able to correlate those 2 sets of metrics together. And at the end of the day, we do tune our alerts based on our workloads. So the 80 and 2.5 on the slide are what we use for our R&D gateway. They're throwing the most amount of data at and pulling the most amount of data out. You can definitely size those alerts based on what you need. We do take a monthly snapshot of these averages and take a look at how are we trending. You can see we're on the graph, we're starting to take a little bit more of a hit. So we're starting to take a look at should we be resizing the cache that's supporting this volume. The really cool part for us is backup and restore. So I'm sure everybody's been in this boat. You back up big chunks of data. You're pulling it over a WAN, you're pulling it to tape. There's obviously great products from Amazon around VTL where you can get that up into the cloud. For us, rather than having that secondary, we are using EBS Snapshots built right into the gateway to do our backup. So depending on the workload, depending on the data classification, we are snapshotting that volume every hour, every 4 hours, every day. So that gives us our point-in-time snapshot, and that is a snapshot that we have available right away. We retain those snapshots, again, based on what the business requires. So if the business needs all their data forever, every day, that's what we do. If they don't, which is most often the case, we use a Lambda script to clean up those old snapshots. So going through and saying, hey, after 90 days, we're only going to keep the last snapshot of every month, and that gives us kind of that point in time. For us, the real win, great, you can take an EBS snapshot, but the restore process for us is really, really valuable. So we've got a warm storage gateway appliance sitting up in AWS, and we've got a warm Windows file server sitting in DFS, ready to go. If we need to do a restore, we just attach that volume snapshot into that warm gateway, and we've got our files ready and accessible in 10 minutes. We can pull the data right away. Often 10 minutes is kind of the max. It can be a lot less than that sometimes, which is pretty powerful. To say, hey, I've had a site go down, or I need to get these files back right away. 10 minutes to do a restore, to have that data available is pretty powerful. If we lose a data center, if we lose a site, the real value for us is it takes us about 30 minutes, and we can have that entire file system, that entire share back online. And to be honest, most of that time is DNS changes propagating for DNS, or DFS, sorry, to update. One point for you, and this is certainly a gotcha that caught us initially, VSS not supported by Storage Gateway. If your users are used to using previous versions in Windows file system, it's not going to work. It's good and bad. It's great that we can restore really quickly if our staff need data back. The only downside is we now have to do it. IT needs to do it. So if you need a restore, your staff have to come to you and ask, and then it's something that your team has to take on. We typically don't find we're doing a lot of restores, so it's not a big deal for us. But again, that is just something to keep in mind. Talking a little bit about how we size our gateways and what it looks like in the real world. So my best recommendations to you are, if you're going to do this, if you want to do this for real, buy really quick hardware and put it on dedicated hardware. So your gateways are always going to work best when they're not fighting for CPU cycles, when they're not thrashing disk. We will typically hard pin cores in VMware and make sure that it's got lots of CPU so that we don't have any contention when we're trying to do file reads or file writes. Again, memory is important, but only to a point. 16 gigs is the max that we found is really useful. Anything beyond that doesn't really make a tangible difference. We like SSD or SAS. We're actually building an NVMe-based gateway right now, and it's going to go all the way up to the theoretical maxes of the local VMs, so 16 terabytes of NVMe-based storage on-prem to support our research groups. That said, we've been running our general files on SAS disk with a good controller for a number of years, and performance is great. We have no concerns. On the disk size, and this is, at the end of the day, you're virtualizing storage. Best recommendation is to split your disk pools. So split your pool for your upload buffer, your cache, and your OS. Make sure they're not sharing disk. We typically size our upload buffers based on our internet connection. So if you're talking about a 5 megabit connection, maybe we need some more upload buffer to let that trickle up overnight. If you've got a gig pipe or a 10 gig pipe, not so much of an issue. We typically use 5 days of the maximum amount of ingest data to size. So 500 gigs more than does it, but that is oversized for us. The cache size itself, we typically do it based on the turn rate and the amount of data that we're going to ingest. So for our research groups, they need about 3 months of data online, and that turns into 12 terabytes. For our general business groups, they're using files for 2 to 3 weeks. 500 gigs usually does the trick, and they're not dirtying that cache or hitting that cache too badly. A good recommendation, do watch for disk contention. We initially had the gateways, just while we were trialing them, deployed on very much shared disk, and we were seeing performance issues when your SQL server is doing a backup or something like that. So watch out for disk contention. That said, we do thin provision our disk, so it is in some of our disk pools, it is thin provisioned, but we don't share those pools. So yes, it's thin provisioned, and there's the opportunity for other disks to come in there, but we're not actually sharing that I/O pool. A little bit of a snapshot just about what we're thinking about next, and hopefully this helps to give you a little bit of insight. So I mentioned that we're building a new gateway appliance right now on-prem, so 16 terabyte NVMe-based VMware hosted appliance. It's just going to be screaming fast for our research groups. We're working on that right now. We're very excited about potentially running an EC2-based direct connect attached storage gateway appliance. So it's a great hybrid model to say We've been running it on-prem. We've got a local cache on-prem. We've now got an on-ramp to Amazon with Direct Connect. Maybe we can just forklift that workload straight up into the cloud. And we are obviously exploring the file gateway appliance as well. That's very interesting to us. On NFS for our research groups, there's some gotchas that we have to work around with the file permissions, but the file gateway not being limited by volume size, basically an unlimited scope of disk is pretty interesting for us. And then the long term is, of course, once we have those files up in the cloud, how do we leverage Amazon's other services to build workloads or to do analytics on that data without us having to think about it. So it's a stretch. It's something that's probably 12 months out for us, but how do we leverage Amazon's compute resources to do something more with that data rather than our staff having to do it themselves? So with that, I'll say thanks, and I wish you the best with your cloud journey, and I'm going to turn it over to Paul.
Thanks, Adam. Always really good to hear how our customers are using the services that we build, and thank you for being a customer. So we're going to switch gears now and talk about what's under the covers. Adam's given us a good view as to how he's using the service, so let's talk about some of the things that go on inside the service that enable this sort of use case. So as Asa mentioned earlier, Storage Gateway comes in three types: file, volume, and tape. And there's some very common capabilities or common design traits that all of those gateways have. First is that they're all deployed as a VM. So the service is access to a VM that works on either VMware, Hyper-V, or in cloud on EC2. No matter which gateway type you're using, the gateway really is providing you three main features. One is it's providing you protocol transformation from iSCSI or NFS to the back-end protocols that the AWS storage services use. The other is it's providing device emulation. This is really important when we talk about tape gateway. We had a session yesterday that was a packed house, going into a deep dive on that, where we provide emulation of a virtual tape library. Third is, the second rather, is that the gateways are providing caching, and that's really important for that low latency access to your hot data. So while all of your data is stored in AWS, some of your applications want lower latent access to that. And so by the VM holding that cache close to your applications can read and write that hot data that's in the cache. And then, as Asa mentioned, we also provide optimized transfer. We use firewall-friendly HTTPS to move the data from that VM to make it sure it's durably stored in the cloud. So for anybody who was here last year, we launched File Gateway last year, this time, and we've had a dozen launches since then on the service. Some of those have been larger features, some of those have been smaller features. And again, as you'll hear a lot during this week, we drive our roadmaps based on feedback from customers like yourselves. So all 12 of those launches have been driven by named customers that have come to us to say, hey, I really want to do this with your service. Help me do that. What can you do to improve the service to do that? A couple of the items here that I'd like to highlight are, and we had HIPAA eligibility, so for anybody who's doing healthcare workloads where HIPAA is a concern for you, service is now on the HIPAA eligible list for AWS. We've expanded the service into all of our commercial regions now, including Beijing. And again, for the file volume and tape, we've had a number of feature launches. The one on the bottom right there that I'd like to highlight came out just before Thanksgiving, so most of you may have missed the news. That is upload notifications, and we'll talk a little more about that when we talk about File Gateway in particular. I won't go into tape in depth. We'll look really at volume and file here, but I did want to mention that the tape gateway is a type of gateway that we offer. The interesting thing about this, and again, just to highlight some of those sort of family values that you get with all the gateway types, is that a customer was caught in the hurricane that happened in Houston recently and was using tape gateway. The data center was flooded out and they lost everything. Now, because all of their data is mastered in AWS, all of their data is really stored in AWS, and the VM is just providing access to that data, they were very quickly able to spin up a new VM in a new data center and access all of their data, restore from their backups, and get online quickly. So again, just super important to recognize that the gateway is really just providing that access point. In terms of tape gateway, we're providing access to the storage and a whole bunch of device emulation to make tape gateway a drop-in replacement for a physical tape library. I'm going to hand over to Everett to talk about volume in a little more depth.
Thanks, Paul. So we're going to go through the two different types of volume gateways that we have, the two different modes that you can deploy in, how they work, and then how you can also use them for things like data protection, taking snapshots, maybe helping with your backup and your disaster recovery strategies. So as Paul said, all of our storage gateways are deployed as virtual machines. So the volume gateways that Adam is using at STEMCELL, deployed as virtual machines. They make a connection back into AWS. Everything is encrypted. So any data that's leaving that appliance, that's traveling over a direct connect or traveling over the internet, all of that data is encrypted before it leaves the appliance as it's traveling over the network back into the service. I mentioned there are two modes. The first mode is volume stored. With volume stored, this means that 100% of the data on that volume is inside of the virtual machine and inside of your data center. So if you have a workload that's extremely sensitive to latency, that needs to have all of that data that you cannot wait for it to be retrieved from AWS from the service, volume stored can help solve that problem. It also means that you need to have all of that disk available, and the disk needs to be performant. So if you have 12 terabytes of data, you have to have 12 terabytes of available disk, plus probably some room to grow, and all of that data will be stored locally. So that means that any writes that happen go directly to that disk. They're acknowledged locally. Any reads that happen come directly from the virtual appliance from that disk, hadn't they happen locally. All of the data is transferred up into AWS over that encrypted connection. It's stored in S3 as part of the Storage Gateway service, and it is compressed, and the data is also encrypted before we transmit it. So not only are we encrypting the network link, we're also encrypting the data itself after compressing it and then sending it up, and we store it in the service compressed and encrypted, so it's even protected when it's on disk. And one of the interesting things that you can do with stored volume is you can actually take a LUN that is inside of your data center today that has data on it, it has a file system, it's been formatted. You can present it to the storage gateway and use the storage gateway to present that back directly to the application server. And so that means that you can take existing data inside of your data center and get it transferred up into AWS, and there's no change to your application other than making an iSCSI connection into the gateway. You don't have to reformat the volume, you don't have to copy the data, you don't have to write a new disk signature, because you're connecting to the same volume that that application has been using for years. So it's a very easy way to shift your data into AWS, to be able to get the durability that we provide with our storage services, to be able to take snapshots and protect, and then someday potentially even move your application up into AWS without having to do a forklift move of that data because you've moved it up with the storage gateway in advance. So that's stored volume mode. We also have cached volume mode, and this is what Adam talked about a lot. This is what he's using at STEMCELL. With cached volume mode, you can think of this as a virtual volume or thin provisioned. This is where you have some amount of cache in your storage gateway virtual machine, and that's doing your reads and writes, that's acknowledging and that's serving up local reads if the data's in cache. But it's less than the amount of data that's stored in the volume. So this could be, I think 500 gigabytes was your sort of general file services of cache, but you could have 10 terabytes of data sitting behind that. Just to see if it would work, I did something very silly. I don't recommend anyone doing it. I took 32 terabyte LUNs, which is 1 petabyte of storage. I presented it to a Windows server, and I gave it 100 gigabytes of cache. And I can read and write data to it, and Windows sees 1 petabyte of available capacity. The reason I don't recommend you doing that is because if you really have a petabyte of data, you're going to overrun 100 gigs of cache incredibly quickly. So it was kind of a science experiment just to see if I could make it work, and it absolutely worked. So with the volume gateway and even the tape gateway that Paul mentioned, you can see that we have an upload buffer and we have cache, and Adam talked about how they manage those and monitor and even size. But one of the things that's interesting is when you do a write, that data goes to the virtual volume, it gets stored in the cache. We then compress and encrypt as it gets moved into the upload buffer. So that's one of the services that the upload buffer provides, is we can store the data locally in the cache in the native format, but before we compress it and encrypt it, we move it off to a different place so that we're not affecting performance from the cache for reads and writes. So as the write happens, it comes into the cache and it's right back. So that means that you get that local acknowledgement very quickly, just like you would if you were writing to any enterprise storage array that was fully kitted out and you were storing the data there. Then it gets transferred up into the service. For a read, if the data is in cache, we serve it locally from the cache. There's no latency. Everything happens directly inside the data center. If the data is not in cache, that means that we have to go out to the service. We have to download that data, put it back into the cache, and then we service the read out of the cache. So it's write back, read through. We also offer snapshots and clones. And snapshots utilize the EBS Snapshot service. Clones are really sort of checkpoints that are inserted in the data as it's being uploaded from the gateway into the AWS service, into the Storage Gateway service and stored in S3. And they give you kind of rollback points. They also give you the ability to create new volumes. And you can create a new volume as a clone. You can also create a new volume from a snapshot. If you create a new volume from a snapshot, you can either give it to a new Storage Gateway instance, or you can also give it to an EC2 instance. And so when you combine that with something like stored volume, where you have existing data in your data center, you can get it all transferred up into AWS, take a snapshot, use that snapshot to generate a new EBS volume, and attach it to a development environment, attach it to the application that you've now moved up into the cloud. So it's a very easy way to be able to make that transition and move that data. And you also have a lot of flexibility once the data is inside of AWS for where you can reuse it, things that you can do with it. Maybe it's a development environment and you want to test on live data. Take a snapshot, give the snapshot to the development team, and let them test on data that was current as soon as the snapshot was taken. Now, when you take a snapshot, you can see here we've got A, B, and C. All of that data has been written through. It's stored in the local cache. A has been compressed and encrypted and is in our upload buffer. B is in process, and C hasn't quite gotten there yet. A has been moved into the service. B is in flight. C is still working. When you click the button to take the snapshot, or you trigger the API call, or you have a Lambda, speaking of, I have an IoT button that if you click it, it takes a snapshot of a volume. If anybody wants the Lambda code, see us in the back afterwards, and we can give you a copy of it. As soon as you make that call, the service says, okay, we're going to take a snapshot. It inserts a marker so that we know what data is in the cache. We know what data is in the service inside of AWS. We know what's dirty. We know what's clean as far as the cache is concerned. We wait for the rest of the data to be transferred up. So you can see now we've got A, B, and C are all stored in the service. Now we use EBS snapshots. An EBS snapshot service will make a copy of all of those blocks into S3. And we have the data there, so it's available, and then it responds back snapshot complete. So it's pretty straightforward when you're taking a snapshot, when you're restoring from a snapshot, even when you're cloning a volume. And you can do snapshots either to a storage gateway or directly to an EC2 instance through EBS. And clones, you can take and give those to either the same storage gateway or to a new storage gateway. And I'm going to hand it back to Paul.
Thanks, Everett. Great. So we'll switch now from volume to file. File gateway, as was mentioned, is a little different to tape and volume, where in this instance we store data in one of your S3 buckets. And this we introduced last year, and a lot of customers have not only thanked us, but made some really interesting use cases using file. The gateway deploys as a VM. You connect to it using NFS, so your file-based applications see a shared file system. And the gateway manages data locally using a cache, similar to what Everett was just discussing, and uploads files one-to-one. So a file that you write to the gateway through NFS appears as an object in S3, a native object in S3. We don't mess with your file, so if you upload something, you'll see the same namespace in S3 that you have within your file server. We store file system metadata as object metadata, so that's durably stored in S3 again. It's not stored on the gateway. The gateway is stateless. If you were to deploy another gateway and pointed at the same bucket, you would get the same file system back. Really, really important. And we use a lot of the native capabilities to give you full access control over how your data is stored and managed. And we'll talk about some of these as we move on. So as I mentioned, a really neat feature of File Gateway is this one-to-one mapping of objects. Now what this provides is not just a namespace on both sides that your applications understand, that you understand, but it also means that the objects in S3 can be managed using native S3 capabilities. You can now write life cycle policies, my apologies, or tag objects based on names that you understand. We're not sharding data or putting data up with GUIDs that you don't understand. So it's a single namespace across both object and file storage is really neat and really powerful, especially when you are using some of these native S3 capabilities to manage your data. We give you a lot of control over how your NFS clients can access that data from a POSIX permissioning standpoint, file system permissioning standpoint, and how the data makes it up into your S3 bucket using some of the native S3 capabilities. You control the IAM policy that writes to your bucket on a per bucket basis. You can choose what storage class to put your data into. You can encrypt with a KMS key, or a feature that we just added last week for a number of customers who are using File Gateway to move assets up into S3 to then distribute with CloudFront to support websites is the ability to guess MIME type, something you can do with the S3 CLI. Now you can do it when you're writing files up through File Gateway. Inside File Gateway, there's really two things. So with volume and tape, we have an upload buffer and a cache. With File Gateway, we have a metadata, an object inventory, and a cache. The metadata inventory gets used to provide low latency access for file system operations. If we had to go to S3 every time you did an LS, it would be really slow. So the gateway keeps an inventory, and again, we cache that inventory, so we roll through it, keep just the hottest data in cache. We provide an API in order to refresh that inventory. So for example, if you have a workload in cloud that's writing into your S3 bucket, and you'd like to expose the objects that are now in your S3 bucket as files, you can call the API to tell the gateway to go look in your S3 bucket, and it picks up new metadata and new inventory of the objects. We don't exhaustively wander your S3 bucket. We just keep the data in there, similar to our cache that's hot. A new feature that we launched last week is the ability to emit Cloudwatch events. Now, this is really useful when you've got a file-based workload that's writing data into the gateway, and you want to know when that data is available to an object-based workload in S3. So you can ask the gateway to tell you when that data has been uploaded, an upload notification, in which case the gateway will upload the data. And once the data is uploaded, you'll get a Cloudwatch event that you can hook to a Lambda function or hook to other workflows. So similar to Everett's slides about file, and I'll go through these reasonably quickly because time is pressing. Reads happen from the cache, and once, if you get a cache miss, we'll go down to S3 to fetch that data. We try and do byte range gets as much as we can, so if you read a file in part, we won't necessarily pull the whole file into the cache. We have a bunch of heuristics in the gateway that try and do smart read ahead and some prefetching. So for example, if you're doing something like you start to read a video file that clearly you're going to read serially front to back, we'll see that you're doing that, and we'll start to prefetch ahead of your operations. This is really useful for doing things like streaming videos or media to avoid buffering and to avoid the latency of doing demand caching. On the write side, similarly, we write to the cache first and then asynchronously upload. As Asa mentioned early on, we do a lot of data optimization to move that data from the gateway into S3 as efficiently as possible. We use multi-part extensively. We use parallelism extensively. So let's look at how updates happen, because this has been a source of questions from many customers. S3 obviously is a write once object store. You write an object, they're immutable. You can overlay an object, but you can't change it. So how do we then surface files, which are inherently rewritable things, in a immutable object store? So suppose we have an object here that has ABC in it. That obviously is easy. I can upload that as a single put into S3, or a single multi-part put. Suppose you append D to that object. So what do? Well, We upload just D, and then we use the data we already have in the cloud to create a new copy of that object, which is ABCD. So we don't upload A, B, and C again. We upload just the change data and then use data we already have in the cloud to create a new object. Similarly, if you append E and F, again, we'll upload just the data that you're sending, just the data that you've appended, rather, and we'll use the data we already have in the cloud to recreate that object, that version of the file, with E and F appended to it. Right to the middle of the file, same thing happens. So we're only going to upload the changes and then use server-side sort of reconstitution of the object to create that file and make it durably stored in S3. Now, an interesting thing to note here is that you'll notice that A's only ever been uploaded once. You're like, will this work if I go back? A gets uploaded initially, but is never uploaded. He's always copied down. So if A wasn't in cache, I can still recreate that file in S3 as an object. So following Everett's silly science experiment with surfacing a petabyte of data on a gateway with 100 gigabytes of cache, I have my own silly science experiment, which is appending 1 byte to a 1 terabyte file on a gateway with 100 gigabytes of cache. And the reason I can do that is I don't need that whole 1 terabyte file on the gateway to be able to manipulate it, to read or write it. The gateway is providing me access to that data and is pulling bits into the cache as I need to read them. Or in the case of a write, he's writing that 1 byte up and he's using the data that's already in cloud to recreate that 1 terabyte plus 1 byte sized file. So a really neat use case, gives you obviously access to buckets significantly larger than your local storage, entirely transparently through the gateway. Let's talk about how some customers are putting this again. Again, Adam gave some really good use cases from their side. I'm going to cover quite quickly a couple of use cases, how customers are bringing some of these features around some of the APIs that we have and some of our metadata management. So here's a very traditional setup. Customer has a gateway on-prem in their Los Angeles office connected to our Oregon region. In this instance, they also have another site in Denver that needs access to this data, so they're using us for content distribution. In this instance, their LA HQ writes data into the S3 bucket. When the upload notification arrives to say that data is there, they can call refresh cache on their gateway in Denver, and those files that they wrote in LA that are now mastered in S3 are available to clients in their Denver office. So a really good way of doing content distribution, where you have a central site and you want to disseminate data out to other sites. Write it in one place, refresh the cache on the other gateways, and that data is now available as files with all of the POSIX permissions that you wrote them with available to those other sites. We have another customer who's running a global call center. And in this instance, the data that they're putting into S3 is call logs from their US-based call center. They want those available off hours to their off hours call center down in Australia. And in that instance, they're using S3's native cross-region replication capability to replicate those call logs between 2 buckets. They also have a regulatory requirement to have these things in 2 places, geographically separated. So they're using S3's native cross-region replication, replicating these objects. Again, they're just objects over to Sydney, and then they have a gateway in their Sydney office, their Sydney call center that's accessing that data. Again, they can use refresh cache and upload notification. In this instance, they use a scheduled refresh cache to pick up the data as the shift changes over. If they didn't have a site, we also provide an EC2 gateway, so they could equally run an all-in-cloud off-hours data center if they wanted, spinning up a storage gateway AMI and then accessing it from EC2 instances as files. And the last use case is customers are using Snowball. So sometimes you just don't have enough bandwidth to move all this data into S3. And so customers are using Snowball Edge, the file interface on Snowball Edge, to write data to a Snowball Edge. That data then gets shipped into AWS, transferred into their S3 bucket. Then that becomes available back to them online through File Gateway as files. Now, the interesting thing, or the neat thing there, is that we use the same metadata formats between Snowball Edge and File Gateway. So if you write files to Snowball Edge, all your file metadata is attached to them when they go into Snowball Edge. They go into S3 when they're surfaced back to you through File Gateway. The same metadata is on them. So your file system remains intact, even though you're shipping some of it on a Snowball. Kind of neat. This last use case is a really new one because it uses some of the Cloudwatch events that we just launched last week. Again, a very traditional setup here where we have a customer who has a set of devices. In this instance, they're wet lab devices that only talk file. So those wet lab devices use a file gateway to write data up into S3. When the data is uploaded into S3, a Cloudwatch event gets triggered to say there's new data available. And the customer's then using Athena to do in-place analysis on that data in S3. That Athena job then writes data back to the same S3 bucket, result sets, if you like, and tells the gateway to surface that data to refresh its cache. And then the users down on the bottom left there have access to the result set from Athena. So in this instance, they're uploading large images coming off mass spectrometers. They're doing feature analysis on them with Athena, and then they're pushing the data back to their scientists through S3 and through the gateway. That kind of wraps up the storage gateway. I just wanted to point out that all of this training, all of the sessions here, you can use for certification. Good for anybody that's trying to get their hours in. And do the little advert for all of the other sessions that we have going on this week. I mentioned that we had a tape session last week. All these will be recorded, available after the event, but obviously attending them in person is a slightly different feeling, and that's why you guys are here. So thanks for coming. We will take some questions if anybody has them, and fire away. Oh, yeah, and for anybody that's interested, we actually have a Birds of a Feather session running tonight. So for anybody who wants a sort of a more intimate one-on-one, please come up and talk to us, or talk to Dylan in the back there, who's holding his hand up. You mentioned that the volume gateway is encrypted at rest and in transit. Who maintains the keys for the encryption at rest? Can I generate those on my on-premise data center and maintain them in my own key management system? So for volume gateway, you had a mic, sorry. So for volume gateway, they're S3 managed keys today. Customer managed keys is something we're looking at on our roadmap. For file gateway, we allow you to use KMS. So SSE S3 by default, SSE KMS is an optional configuration today.
Here for Adam.
Yeah, I'm just kind of curious. You said that you're on 45% roughly AWS right now. About how long and what were some of the challenges you had in getting from a typical on-premise data center posture to having that much of a cloud presence from an operational standpoint?
To be honest, we started growing with AWS a number of years ago. It was a cool technology. It's very easy to get a young, motivated staff interested. So we're a 20-year-old company, but our team is pretty agile and pretty nimble. So it helps when you've got the internal technical team moving. But at the end of the day, it's, I'd rather not buy another data center. It's very easy.
Yeah, can you pin a folder or a directory and a NFS cache to a hot standby site on another storage gateway?
Not sure I understand the question. So you can expose a bucket, or you can mount a bucket from multiple gateways. We recommend that you don't have multiple writers to the same bucket. So if you look at some of the content distribution examples that I gave, those instances they're using read-only exports from the secondary gateways in those other sites.
So when you refresh the cache, does that mean the cache in another site gets all the new data into its cache? Okay, good question, yes. So when you do a refresh cache, we're just refreshing the inventory of objects. We're not prefetching data into the cache. We're not cache warming. That's something that we're looking at because we have a number of customers, again, in the sort of video streaming space that want to not just make the video files that are in S3 available to those other gateways, but pre-stage them on the gateway, on-prem, if you like, so that the application isn't having to demand cache at all, or use some of our heuristics to do prefetch. So they know that there's content there. They know they're going to want to read it, know they have an application that's going to want to read it, so should we just push it up there? So as we start to evolve that cache refresh capability, we'll add additional parameters to allow you to do sort of pre-warming of the cache in those other sites. Is that like a near roadmap type of feature, or is that?
That's something that we're looking at for this next year. We haven't nailed down timelines.
Yeah, it's a little more, I think I'm turned on. Oh, there we go. It's a little more labor intensive, but you can certainly always take data that you want to get into the cache and cat it into dev null.
Right.
You know, it's not fancy, but if you want to sort of pre-warm the cache on a remote gateway that the data didn't go through, it is a way to get it there and make it available. So, you know, you do that in off hours, and then the next morning an end user isn't going to see any latency or lag as that data is downloaded to the cache.
Yeah, so again, I said this earlier and I'll say it again, that you'll hear this a lot, that we drive our roadmaps based on feedback, and once we start seeing 2 customers doing the same thing, we tend to realize that that's something we should just absorb as a first-class feature, and this idea of pre-warming the cache on remote gateways is something that we've seen a couple of customers do by playing these cat to dev null tricks. And we can do that obviously much more efficiently within the service for you. So why make you guys do the heavy lift? We'll just make that a core feature.
Question here.
Say on the west coast of the United States, with enough gateways and buckets in aggregate, would we be able to get, say, 20 or 30 gigabits a second of read-write throughput?
Gigabits. I'm trying to do the maths in my head. So 20 gigabits.
With enough gateways and buckets.
Excuse me. So the current design point for a single gateway is 1 gigabit per second. And you're looking for 20 gigabits a second? So with 20 gateways today, you could do it?
Okay.
How does the storage gateway work with the buckets that have been transitioned to Glacier storage class? Does it automatically rehydrate on demand, or can you elaborate on that?
Yeah, so the way it works today is that the files will still appear in your file system, just as an object that's been transitioned to Glacier would appear in your S3 bucket. You'll still see all of the metadata around that, so the name will still be there, the timestamps and the permissions. If you try and read the file, you'll currently get an I/O error, so you have to transition it back with S3. Love to talk to you about what your use case is, because we see a number of customers wanting to do this. And some customers are saying, well, just retrieve the object for me, but obviously there's a cost incurred to doing that kind of transitioning. So we need to figure out how much we do this automatically for you versus making it an option, because we obviously don't want you doing a random application to wander your entire file system and transition everything back from Glacier, obviously at cost, and that's not really where you wanted it anyway. So let's talk about your specific use case and about the sort of configuration you'd like around that. Today, it's a little less clean than we'd like, because you then have to go back to S3 to force the transition. But we're looking at providing a sort of a file system way of doing that. There's a couple of options I can talk about. So.
I think we're down to our last question. We have 1 minute and 52 seconds left on the timer.
I think actually we've probably got the hook. We're more than happy to take questions outside. I know they want to transition over to the next session. So thanks all for coming, and have a great reInvent.